So pavement preservation is often described as one of the most cost-effective ways to extend road life. How can Department of Transportation engineers plan and apply proactive treatments across the life of a road to stretch limited budgets and improve long-term outcomes?
Some of the newer technologies, like this J-band VRAM that we've launched, they have a very proactive core to their value proposition, which means that you actually put them down, even though they're a preservation technology, you place them at the time of construction. So we call it a pre-preservation technology because most preservation is a reactive action to a problem that's developing.
Did you know that waiting until a road shows signs of distress can cost 2 to 3 times more than preserving it proactively? In this episode, I'm joined by Dave Henderson, Executive Vice President of Business Development at Asphalt Materials, Inc., to explore how proactive pavement preservation is helping engineers stretch limited budgets and deliver long-lasting roads. We'll discuss why planning treatments across the life cycle of a road is critical, how innovative technologies like Void Reducing Asphalt Membrane, VRAM, and Rapid Penetrating Emulsion, RPE, are making pavements more durable, and how organizations like FP2 are shaping data-driven strategies nationwide. With VRAM adoption accelerating across the U.S., this conversation comes at a pivotal moment. If you're a civil engineer committed to building sustainable, cost-effective infrastructure, this episode is for you. Before we jump in, I wanted to tell you about our AEC PM Connect event, an interactive experience where civil engineers can sharpen their project management skills through real-world sessions on topics like earned value, AI in project management, and risk management. Visit aecpmconnect.com and register today. We currently have events in Kansas City and New Jersey with even more coming. I'm your host, James Taylor, and this is the Civil Engineering Podcast, the industry's leading show for civil engineering professionals, ranked as the #1 civil engineering podcast by FeedSpot. It's now time for our civil engineering conversation of the week with Dave Henderson, Executive Vice President of Business Development at Asphalt Materials, Inc. Dave, welcome to the Civil Engineering Podcast.
Thank you, James. It's a pleasure to be here with you today.
Dave, what was it that first drew you into the asphalt industry, and how has your career path led to your current position as Executive Vice President of Business Development at Asphalt Materials, Inc.?
Yeah, I would say I entered it by accident, but I've stayed on purpose. So growing up in Kansas in the 70s and 80s, when the huge oil boom was going on, Koch Industries was a very large oil company based there in Kansas, and they recruited heavily from the Midwest. During undergrad, I met an executive from Koch and just really opened my eyes to the opportunities that were available for a farm kid from rural Kansas. So ultimately, I joined their asphalt team. I trained technically at the refinery up in Minnesota and then had commercial roles all over the country. And working with civil engineers really deepened my appreciation and interest in the materials technology side of our industry. And so after 35 years, I have stayed in the industry and now enjoy my role here at Asphalt Materials, which is a division of the Heritage Group.
So pavement preservation is often described as one of the most cost-effective ways to extend road life. How can Department of Transportation engineers plan and apply proactive treatments across the life of a road to stretch limited budgets and improve long-term outcomes?
Yeah, that's a great question. There's really two different ways to answer it. Some of the newer technologies, like this J-band VRAM that we've launched, they have a very proactive core to their value proposition, which means that you actually put them down, even though they're a preservation technology, you place them at the time of construction. So we call it a pre-preservation technology because most preservation is a reactive action to a problem that's developing in the market. And so in terms of being proactive with the more common preservation technologies like chip seal or microsurfacing, I think it's the agency engineer having a network mindset and really thinking about having to take care of this entire network rather than fixing that one problem road. And that then becomes the loudest noise is this, everyone complaining about this
wheel,
road. Yeah, the squeaky wheel theory.
So what is it about pre-preservation? Talk a little bit about the difference between the two.
Well, pre-preservation is really a phrase we have just coined to try to help people understand that this actually takes place during the construction process. Most of the times you think about your house, you usually paint your house after the paint has aged, then it's time to repaint it again. We're saying maybe this would be considered like siding. This is something you do at time of construction that you don't have to repaint it as soon.
You talked a little bit about some of the other technologies with the, the restoration or the repavement
Hmm.
after the fact, the slurry seals,
Hmm.
the micro surfacing, those types of things. Eh, what's been your experience with those? And it seems like, hey, as years go along, we get some new technologies that come along with it.
Right. I would say you have to think about those portfolios of products like a toolbox. And, each road needs a different tool to get it fixed.
Mhm.
And so we've seen them evolve over the years, but fundamentally, it's about using asphalt cement as a waterproofing medium. And then the stone is usually for either structural value or sometimes it's just to keep the cars out of the oil. When you do a chip seal, that oil is going down to protect the road, and we put the chip on it so that there's a frictional surface and that the cars can actually drive on the pavement before the oil is fully set up.
Mhm. So you threw in an acronym there in one of your previous answers about VRAM, and
Hmm.
I believe that stands for Void Reducing Asphalt Membrane.
That's it.
So combining that with Rapid Penetration Emulsion, which I believe is acronym RPE,
Hmm.
these things are gaining more attention in the field. Could you explain how each of these technologies, how they complement each other, and what advantages they provide to road durability and cost efficiency?
Well, absolutely. And if I was to give you an example, I'd say the best example is the Indy 500 track, which has both technologies on it. And, that racing surface was previously replaced every 7 to 9 years. And I think this was his 25th race since we put those technologies on it.
Wow.
So what they do is they work together, but they do it in a very different way. So the VRAM technology, as I stated earlier, is put down before you actually pave. But it's trying to solve the same thing. We're trying to keep water out of the pavement and out of the underlying layers. So VRAM, you put a band of it down and then you build your longitudinal construction joint on top of it. And fundamentally, it's a large amount of material. It's like a gallon a square yard of oil, which is a lot. But that oil, when you place hot mix over it, between the temperature of the hot mix and the pressure of the rollers, that oil basically migrates up into the mix and both reinforces and waterproofs it. And so that's very important for any pavement joint, but it's very important, which I'm sure we'll talk about later on, when you're using rumble strips, where you're cutting in places for water to get into the pavement easier. RPE, on the other hand, is just a newer technology to an age-old process. We've been fog sealing roads for
Yeah.
decades, and this is really it's a fog seal, but there's two key words that are letters R and P. So it's rapid and penetrating. So it's just meant down to get down off the surface. So if you think about a traditional fog seal, like laying a layer of saran wrap on the road to try to waterproof it, this is meant to migrate down into the mix and fill up not all of the macro texture so that the stripe still has a place to stick on the road. So you can imagine VRAM you put down first,
Yep.
it works its way up from the bottom. RPE works on the top. You can use them mutually exclusively. Together, they make a great package to protect a joint.
Yeah, I know. I know around me, a lot of my neighbors always are complaining about the tar and chip solution for asphalt, and hey, we got stones on the road for years to come, and it's a hassle. It's a little bit more slick and all this different stuff, and as an engineer, I have to remind them like, hey, this is actually a really good thing. Of instead of having to go through and replace that entire asphalt section, it's providing a little bit more longevity to what you might not always be able to see. And it's
100%.
interesting how all the different you mentioned it, how all the different technologies that are out there for extending the life cycle of a road, the more that you're able to do these up front, which is kind of where you're talking about, the better it ends up being.
Even if upfront means that you have a plan to do it in the future at the time of construction, you may not actually do it then, but you know that it's coming and you budget accordingly. And that's thinking about your network infrastructure versus just taking care of this road.
Generally speaking, do you think that across the US that a lot of towns, municipalities are struggling with keeping up with their road preservation and restoration schedule?
Without question. I mean, look at the grades we get from the American Society of Civil Engineers every year. It's, you know, money isn't gonna fix this problem, right?
Right.
Yes, they're struggling. It's gonna take technology to fix it.
So VRAM adoption is accelerating across the U.S. with growing support in states like Arizona, Utah, Indiana. What factors are driving this momentum, and how do you see it influencing industry practices nationwide?
Yeah, well, it's really two things. Number one, success breeds success. So we put down probably close to 10,000 miles now, and we've had very good delivery on our value proposition. These joints are still intact like the day they were built. They're maintaining their impermeability and they're lasting. But I think the second and the bigger thing, and the reason podcasts like this are so important, is it takes a courageous engineer to be innovative in this
Yeah.
space, right? You could just do the same old thing the person before you and the person before them did. But as I said before, we're going to have to innovate our way out of this problem because we just don't have the money to solve it with dollars. And so I think VRAM is riding that wave. We've delivered on a very scientifically based value proposition. It's working. It's easy for contractors to use. The spec is very transparent and doesn't prohibit, other people from trying to build it if they have a better way. So I think it's a combination of an engineers' willingness to innovate, and then you have to have good policies. So we act more like good products. I was going to say we act more like an insurance policy. We're
Yeah.
really incremental in terms of dollars to build this road, but you can build a good joint without using a technology like VRAM, but everything else has to be perfect. Has to be the right weather. The mix has to show up at the right temperature. You better
Yeah.
have the right crew. We're an insurance policy. So when it works and it's economically advantageous, you see growth like what we've seen.
Yeah, I mean, a lot of it has to do with, right, that, there probably is a little bit more cost up front, but it's probably pennies compared to having to replace the entire roadway every, so many years. What are you guys seeing from that, with the VRAM or the RPE, that those types of things, what the extension of that life cycle of that roadway, what number of years is that
Well, we
adding?
look at it a little bit different. That's the
Okay.
right question. So to answer your question
Yeah.
directly is, pavements are designed to last 15 to 20 years, depending on the type of mix being used.
Right.
Usually the longitudinal joint is beginning to fail in less than 7 years. I
Hmm.
mean, it is just not lasting like the rest of the pavement. The problem is, especially when you have a cross section with a slope on it, if water gets into a joint that's on the high side, it
Mm.
gets underneath all those other layers. And so we've really brought about this focus on, let's focus on the joints. That's not the most talked about part of the pavement. We think about the wheel path, smooth
Right.
rides, wheel path cracking, but those joints are the impetus for a lot of other failures that we're then having to deal with very expensively.
Interesting. So you're also part of an organization called Foundation for Pavement
Hmm.
Preservation, or FP2. And organizations like that, resources such as roadresource.org, are
Hmm.
helping engineers shape smarter pavement strategies. From your perspective, how are these resources and initiatives advancing best practices nationally?
Yeah, I think the biggest thing is awareness. And it's awareness both at the federal government level on the importance in investing in things like preservation,
Mhm.
but it's also an effort that we have right now to try to take technologies that are new to an engineer, not new to the world, but a lot of engineers, they only know what the contractors around them are doing. So maybe
Right,
microsurfacing is a great example. If you are in some small county in Ohio and you've never seen that before, that's new to you. And so what
right.
FP2 is doing is we're working with some senators in New England, some Congress people in New England, to try to enact legislation that would earmark money for small agency
Hmm,
engineers to try new to them technologies, not new. And to keep this
right.
unbiased, we're going to work through the LTAPs, which are usually affiliated with the university. Here in Indiana, they're affiliated with Purdue. So it's, again,
Yep.
we're not influencing it. It's government money through a public institution going out to a small agency to try something new. In exchange for
Hmm,
that, they have to study and share their learnings with all the small agencies around them.
yeah.
And so we're trying to de-risk what it's like to try something new because, if an engineer tries something new, the failure is going to be immediate and the benefit may not be seen for 10 years. So that's a different risk profile than when you're in the private sector. It's hard for them
Yeah.
to take on something that's new to them. And so we're trying to do that with agencies like FP2. Road Resource, you mentioned, they're really a repository for that information as it exists today. So if you
Mhm.
want to learn more about micro or chip seal, they have a fantastic website with a lot of resources. FP2 is just trying to really make it tangible and put that in the hands of a small agency engineer that doesn't have
Yeah.
a huge staff to research things like that.
It's always interesting because whenever you talk to a local engineer at a government agency about a new product, the first two things are, one, where's the case study that shows that it
Hmm.
works? And the second thing is, how much more money is it going to cost me? Right? I mean,
Yeah,
it
yeah.
always boils down to that. But it sounds like getting that information out there, and it sounds like this is a great way to do that. Of working with the local politicians to say, hey, if we can earmark some money from this, we can show how these different things are and provide for that innovation. Because as engineers, if we're not innovating, we're just kind of doing the same things we've always done. And that's not really what we're called to do as engineers. We need to be thinking about what has been done well and what can
Mm.
we continue to improve upon to make the world around us better. And I think that's such an important piece of what you were saying there of like, hey,
Yeah.
let's not just do what we've seen, let's bring something new to the table and make it more powerful and
They be palatable.
palatable. Exactly. Thank you. A palatable product or palatable
Mm-hmm.
solution that they might not even be thinking about.
Mm-hmm. Yeah, I mean, we're passionate about that, and it's
Yeah.
really nice to be both on the private side delivering that, but then on the trade association side of coming up with strategies that help not just us, but all of our competitors, right? The best technology needs to find its way to the marketplace, whether we supply it or one of our
Yeah.
competitors does.
Yeah. So, with your appointment as president of FP2, what opportunities do you see for advancing preservation policies and best practices at the national level? I know you mentioned one, but
Mhm.
what else do you see?
Well, bigger than that one is even just fixing the way we fund our highway trust fund. I mean, we are facing a cliff, and we have to find ways to address that. And it needs to be a solution that leaves the decision making process in the hands of the engineer, right? We
Mm,
can't prescribe a treatment. We have to fix the funding problem. Whether you're for or against EVs, they don't pay gas tax. We have to
right,
remedy that. They do
right,
consume road resources. And so, again, that's not a political statement. I don't care what you drive.
right.
It needs to be equitable and that everybody is taking care of the roadways. And that's probably the biggest thing we're working on is I'm actually leaving tomorrow. We have another He'll visit about the
Mm,
upcoming, reauthorization.
yeah. Yeah, and it's a tough piece of it, and I know, where I'm at in Delaware, they've instituted some things of trying to collect on those EVs that are going to go into practice here soon. Of when you go to register your EV, you're going to be paying a fee, but it's not going to be anywhere close to that gas tax number, and it's going to be interesting to see. It is going to take some innovative solutions from engineers from other parties to figure out how do we make sure we're funding for our roadways, because as these continue to grow and you kind of find new resources for your fueling for vehicles, whether it be electric or gas or other something else that we're not even thinking about in the future, how do we make sure we're accommodating for that? Because as we've discussed most of the time today, or a lot of the time today, it all comes down to the bottom line with the finances. And if you don't have the finances to improve your roads, you're just not in a good situation. And it's very interesting to hear. So you brought up the heading to Capitol Hill. You want to talk a little bit about that and of what's coming up for the reauthorization?
Well, it's really those two. I mean, what we're doing now is meeting with various committee members to see what they're considering so that we can craft the right language in support of their efforts, right? FP2 is not a large enough entity in and of itself to really affect change, but we partner with the other entities. We have our priorities. We want to make sure they fit in with what the NAPAs of the world are doing and ARTBA. So we work with other entities.
So Dave, one thing that I've seen with pavement preservation is that it really starts with your pavement evaluation program and seeing a lot with AI coming out. What's been your if have you had any experience with that? Have you seen any of it? And what's your feeling related to those types of things? Is that a good advancement in this pavement evaluation process? Or just curious on your feeling on that.
Yeah. So if you think about it in steps, like if this was a supply chain, you've got the data capture,
Mhm.
then you've got the data analysis. And AI is right now, it's trying to straddle both and it has a role in both. So I've seen things as innovative as affixing cameras to garbage trucks
Mhm.
because they drive the same route all the time. So
Right.
you get a really good time lapse of a road. But where I've not seen enough yet to say that we're where we need to be is the human element of interpreting a crack pattern.
Mhm.
That's a simple one, right? Cracks are different and they mean something different.
Yeah.
They're a symptom to an underlying disease, and it. I've not seen the system yet that has fully automated all of that, the interpretation and the regurgitation of what exactly the problem is. Now they're getting better. I mean,
Yeah.
every year I see a better system than I saw last year. So I don't think we're far off, but we're not there yet today. Very close.
Yeah. Yeah, it's exciting to see. And again, you talk about the innovation aspect of it. This is something definitely that's a big innovation in the payment world is this payment evaluation. Dave, what's one final piece of advice you'd like to share with civil engineers who want to build more sustainable, cost-effective infrastructure for the future?
Mhm. Well, thank you, James. I think I'm going to just harp on what we've been talking about. And it's that we can't spend our way out of this problem. We have to innovate our way out of the problem. And that's going to be uncomfortable because you're going to have to try new technologies and do new things. But I think we all, if we recognize the problem that our funding shortfall continues to grow as our infrastructure ages and demand increases,
Hmm.
and we're the greatest economy in the world for a reason, right? We can move goods very effectively. We can't lose sight of that and get into partisan squabbles over who pays what or this whole what's fair.
Hmm.
To me, there's a difference between equitable and fair. I know I won't get everything that I want out of the next bill, but I sure hope we get it where it's equitable.
Thanks, Dave. To wrap up things, we're going to transition into our civil engineering hot seat, where I'll ask Dave a rapid round of questions that will give you a glimpse into the daily habits, influences, and insights that have helped shape his career. Let's jump into it.
Strong project outcomes need skilled managers and competent leaders. EMI's corporate training delivers expert-led courses in project management and people leadership, plus industry-recognized certification and exclusive premium content to take your team even further. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on corporate training.
Now it's time for our CE hot seat segment of the week with Dave Henderson. All right, Dave, you're officially in the civil engineering hot seat. You ready to go?
I'm ready, James.
All right. Do you have any specific rituals that you practice every day? For example, do you have a specific morning ritual, lunchtime ritual, things that you do daily that contribute to you being a successful professional?
Well, thank you for the underlying assumption that I'm a successful professional first. I appreciate that vote of confidence. I don't think it's a specific activity, but what I would tell you that drives me is I'm a list person. And so I think it's very important to capture the important ideas and make them actionable by building a list of things you want to accomplish. So I try every day to focus not just on the things I need to get done today, right? That's the ringing phone, the email inbox that's out of control, but it's more the where are we trying to go 3 to 5 years, and what steps can I take over the next couple weeks, month, 90 days that's going to stay consistent with that path. Beyond that, I try any free moment to consume information. I read a lot of industry publications, but I think more important than that is I make the time to check in with people who are kind enough to share their time with me, mentors, friends, competitors. I mean, that I really respect what they're doing. I'm not afraid to call them and ask them, why do you do what you do this way?
What's one book that you recommend to engineers regularly, or just one book that you have found to be extremely helpful in your professional and or your personal development?
Yeah, I wouldn't call it an engineering book, but it's relevant to any profession. And when I was in grad school, I was introduced to a book called When Teams Work Best by LaFasto and Larson. And it just really, to me, got me to focus on the importance of building a solid team. And that
Hmm.
solid team is based on everyone knowing their own strengths and weaknesses, and then having the open and honest conversation about the strengths and weakness of the rest of the team so that we can function at a very high level. So I think by good fortune, maybe we're gravitated towards organizations that think like we do, but my company really thinks and manages that way. And so I'm fortunate to be able to practice those things with my team, and I see it really pay dividends. That's my favorite book.
That's great. Thinking back on your managers of the past, picture your favorite manager or managers. What made them your favorite?
Hmm. You know, probably is no surprise, they have the traits of that book that I like so much. To me, a good leader is always very self-aware, right? I don't have all the answers, and my team knows what I'm good at and what I'm not good at. Good managers also hold me accountable to very solid measures. They're not arbitrary. They're not changing. They're communicated on the front end that here's where we're trying to go, and they hold me accountable to that. And I think most important for me is they're very transparent about their thought process. I'd rather hear from one of my leaders, here's my point of view on where the organization is going and how I think you can help, versus would you go do this for me? I'd rather hear your why as to what makes that important. And then I'm very aligned with a leader like that.
I've got one final question, and that's the critical civil engineering career elevator advice question. If you got into an elevator with a civil engineering student and you had about 30 to 40 seconds with them, what career advice would you share with them?
Well, I'm going to have to come back to innovation. I'd say know where you're ultimately trying to go in your career and seek out innovation. Don't wait for it to come to you. For example, take on a project or an assignment that'll help you gain a capability or a competency that'll help get you where you ultimately want to go. Finally, be open to feedback. Good teammates are going to tell you what you can do better to help them. And when you're on a good team, that's very comfortable and healthy. I guess I have one more final. Invest in people and relationships. Build that network, whatever profession you're in.
Dave, I want to thank you so much for joining me today. I really enjoyed the conversation about pavement and everything else, and then even your thoughts here on what's made you a successful professional. Where can our listeners connect with you?
So probably LinkedIn would be the best. Reach out to me on LinkedIn, and I'd love to start a conversation. I'll be part of your network.
Please remember you can find the show notes for this episode at civilengineeringpodcast.com. There you'll find the summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you the best in all your civil engineering endeavors.